last night. We're on lesson 10-1, equations, tables, and graphs. Practice A. The table gives the speed of 3 dogs in miles per hour at the given times. Tell which dog is described in each situation. Number 1. Autumn's dog chases after a car passing their house, then stands and barks. The dog then trots back to the yard where Autumn puts the dog on a leash and they walk together on the sidewalk. So this dog is starting off chasing. So he's starting off moving. Automatically, it can't be dog 1 or 2 because dog 1 and 2 are standing still. So this dog starts chasing a car at 25 miles per hour. Then, after a car passes their house, stands and barks. So he's going from chasing the car to standing and barking. The dog then trots back to the yard. So the dog trots back to the yard where Autumn puts the dog on a leash. So the dog's having to stand still while she puts him on a leash. And then they walk together on the sidewalk. So that is describing dog 3. Number 2, Jordan's dog is sleeping when the family decides to go to the park. So if the dog is sleeping, the dog's not moving. So we're obviously looking at dog 1 or 2. The dog awakes and moves about, wagging its tail. The family and the dog get in the car and drive a short distance to the park. At the park, Jordan runs with the dog. So the dog starts off sleeping and then wakes up and moves about. Then they get in the car and drive. The dog doesn't get up and automatically start running 16 miles an hour. He gets up and starts moving about, then gets in the car, and the car drives to the beach at 45 miles per hour. When he gets out of the car, he's standing there until he starts running with Jordan. So that is describing dog 1. Tell which graph corresponds to each situation in exercises 1 and 2. So this one is the dog starts off at a high speed and then stops, waits, starts walking at a constant speed, stops, waits, and then starts walking at a constant speed again. That is describing a dog that is chasing after a car, then stands and barks, then trots back to the yard, so he's trotting at a constant speed. When she starts putting the leash on him, he's standing still, and then they start walking together. That is describing dog 3, which is number 1. And then the dog is sleeping and starts moving about. He gets in the car. They go 45 miles an hour until they get to the beach, where he stops and waits, and then he starts running with Jordan. That's describing dog 1. Number 5. The table shows the altitude of an airplane during a flight. Make a graph that shows the information. So we're graphing these. This is our X. This is our Y. We've got it at 0, 0. 10, 5,000, 20, 10,000, 30 and 40 are both 15,000, 50 is 10,000, 60 is 5,000, and then the plane lands. So you should have these dots connected to show your graph. And that is what you should have for 10-1. On the back, a tub is being filled with water. The equation G = 5m shows the number of gallons G in the tub after m minutes. Use the equation to complete the table. Then sketch a graph of the equation. So we have our input that's given to us. This is our X, and we have to plug your input in to your equation. So we've got 5 times 0, 5 times 1, 5 times 2, 5 times 3, and 5 times 4. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. So we're going to plot these points. This is our x, this is our y. So we're at 0, 0, 1, 5, 2, 10, 3, 15, and 4, 20. That is the equation, the graph of that equation. Number 2, use the table to make a graph and to write an equation. So we're going to plot these points. This is our x's that goes with our y's. So we've got 0, 2, 2, 4, 4, 6, 6, 8, and 8, 10. That's the graph. Our slope, we're going from 2 to 4, and from 0 to 2, that's 2 over 2, which simplifies to 1. Our y-intercept, where it crosses the y-axis, is at 2. So now we plug these two numbers into y equals mx plus b, and we get y equals x plus 2. Our slope is 1, so we do not have to write that, because anything times 1 is itself. Our last one, number 3. Use the graph to make a table and write the equation. So we're looking at these points and writing them down. For 0, when x is 0, our y is also 0. When x is 1, our y is 1. When x is 2, our y is 2. When x is 3, our y is 3. And when x is 4, our y is 4. So we're going through the origin, so we know that our b is going to be 0. Our slope is going from one crosshair to the other, up 1 and to the right 1, so our slope is 1, which makes our equation y equals x. If our slope is 1, we don't have to write it in front of the x as the coefficient, because anything times 1 is itself. And if our y-intercept is 0, we don't have to write that either, because anything that you add 0 to will also remain itself. So the equation is y equals x.